Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P1128 indicates that the manifold absolute pressure MAP sensor signal is lower than expected. This code specifically refers to the MAP sensor's output voltage being below the normal threshold, which suggests potential issues within the intake air management system. The MAP sensor plays a vital role in the engine management system as it provides essential data regarding the amount of air entering the engine. The sensor is located typically near the intake manifold, where it can accurately measure pressure variations. When the MAP signal is lower than expected, it may indicate that there is a blockage, a poor electrical connection, or even a faulty MAP sensor itself. Understanding the components involved and their functions is crucial for effective troubleshooting. DTC P1128 signifies that the MAP sensor has recorded a signal lower than the operational limits expected by the engine control module, ECM. This MAP sensor allows the ECM to calculate air density, which is crucial for proper fuel injection and engine performance. Understanding the MAP sensor's functionality is key. It detects the pressure within the intake manifold, thereby influencing how much fuel is injected and how the engine runs. Positioned typically on the intake manifold, the MAP sensor can be affected by blockages, electrical issues, or even physical damage. Locating this component allows technicians to assess the physical and electronic aspects that could be responsible for this fault code. Thus, identifying the exact issue with the MAP sensor becomes a significant part of the troubleshooting process. The potential causes for DTC P1128 involve several key areas. One primary concern is poor electrical connections or wiring associated with the MAP sensor. Any corrosion or fraying could lead to erroneous readings. Another potential cause is blockage in the intake air duct, which affects airflow to the MAP sensor, consequently impacting its performance. Additionally, a faulty MAP sensor itself could lead to the signal being lower than expected, which is critical to address quickly, as it can impact engine performance and fuel efficiency. Each of these factors plays a significant role in the accurate functioning of the MAP sensing system, and diagnosing them serves as the first step in resolving the DTC P1128 issue. Symptoms indicative of DTC P1128 primarily include poor engine performance, where the vehicle may struggle during acceleration or appear to lack power. This performance issue often leads to reduced fuel efficiency, as the engine management system struggles to optimize air-fuel mixtures without accurate MAP readings. Furthermore, the illumination of the check engine light, CEL, serves as one of the most direct alerts to the driver that the vehicle has encountered a detected issue. Drivers may also report unusual engine behaviors, such as stalling or hesitation, especially during acceleration. Understanding these symptoms helps technicians accurately gauge the urgency and location of the underlying issue responsible for the DTC. For the first troubleshooting step, turn the ignition switch to the on-to position without starting the engine. This enables the onboard diagnostic interface to function. Then, using the HDS Honda Diagnostic System, check the MAP sensor data in the data list. Specifically, observe if the manifold absolute pressure is reported as less than 54.1 kilopascal, which converts to 16.0 inches of mercury, or 406 millimeters of mercury. If it consistently reads below this threshold for over 5 seconds, the system recognizes this as a concern, indicating that the engine is not receiving the correct pressure readings that it requires to optimize performance. If the MAP is above this parameter, you will move to the next troubleshooting step to diagnose further. In this second step, if the MAP reading was above the initial threshold, clear any DTCs stored in the system using the HDS. After clearing the DTCs, start the engine and hold the engine speed at 3,000 revolutions per minute without applying any load, which requires placing the automatic transmission in park or neutral for manual transmission. Maintain this speed until the radiator fan is activated, which serves as a benchmark for engine operation temperature. Letting the engine idle afterward allows for further observation of the map sensor's behavior under controlled conditions. This process is critical because it can reveal whether the initial issue is transient or if the map sensor maintains a low signal in subsequent checks. Following the previous step, the third troubleshooting step involves taking the vehicle for a test drive under specific conditions. Ensure that the engine coolant temperature, ECT sensor, reads above 158 degrees Fahrenheit, which is approximately 70 degrees Celsius, to ensure proper engine heating. During this test drive, monitor the engine speed to stay within the 1200 to 5400 RPM range, which allows for comprehensive assessment under varying throttle levels. The transmission should operate in drive for automatic or third gear for manual. The vehicle should be accelerated between 16 to 31 miles per hour, approximately 25 to 50 kilometers per hour, under half throttle to mimic typical driving conditions. This step is essential as it tests the map sensor's performance under load conditions and establishes whether it can adapt and relay appropriate signals back to the ECM. After completing the test drive, monitor the onboard diagnostics OBD status through the HDS to check if DTC P1128 is indicated as failed. If it has failed, it signifies that the problem persists, which requires you to check for poor connections or loose terminals specifically related to the map sensor and the engine control module ECM or powertrain control module PCM. Ensuring that these connections are secure is critical, as damaged terminals or corroded connections can lead to erroneous readings from the map sensor. Conversely, if the HDS indicates a passed status, it may suggest an intermittent failure, meaning that the system appears to be functioning correctly at this moment. So you'd continue troubleshooting further by assessing connection integrity. For the next step, after completing the previous checks, turn the ignition switch to the lock 0 position to ensure safety. If all signs still point towards a map sensor issue, the logical action is to replace the map sensor itself. Proceed with unplugging the faulty sensor and install the new unit to ensure that all connections are secured without any hindrances. After replacement, turn the ignition switch to the on position to prepare for resetting the electronic control module ECM. This action is crucial as it facilitates the acknowledgement of the new sensor and enables the system to recalibrate itself for optimal operation after replacement. Once you've replaced the map sensor, the next crucial step is resetting the ECM or PCM using the HDS. This reset allows the system to adapt to the new sensor and clear any stored fault data that may have triggered the original DTC P1128. Subsequently, performing the idle learn procedure is essential as it teaches the ECM how the engine reacts when idling with the new sensor. After these steps, start the engine and hold it at 3,000 RPM until the radiator fan engages, and then switch to an idle state. This systematic approach ensures that the ECM's adaptive strategies are updated, ultimately enhancing the performance and reliability of the new map sensor in the vehicle. To confirm that the troubleshooting efforts have resolved the issue, conduct another test drive following the previously specified conditions, where the engine coolant temperature exceeds 158 degrees Fahrenheit and the engine speeds fall within the desired range. Again, Ensure you drive under the outlined throttle conditions to replicate normal operating states. After the drive, consult the HDS to locate any pending or confirmed DTCs that may be present. If DTC P1128 is still indicated, it reinforces that further investigation is necessary, especially around connections to the map sensor and the ECM/PCM. However, if the code is not present, this step demonstrates successful resolution of the fault code, indicating system functionality has been restored. The final verification step is crucial to ensure that the repair made for DTC P1128 has been effective. Firstly, confirm that DTC P1128 is no longer present in the system after all troubleshooting steps. This helps validate that the underlying problem has been addressed. Next, assess overall system functionality to ensure other related systems are operating correctly without raising new codes. Perform a test drive under typical conditions to monitor the engine's responsiveness and behavior. Observing the engine during these final checks ensures that all defined parameters are met and helps guarantee that the vehicle will perform reliably for the driver. To mitigate future occurrences of DTC P1128, engaging in preventive maintenance strategies is vital. Regularly inspecting connectors associated with the map sensor can prevent oxidation or damage that might otherwise skew sensor readings. Ensuring the intake air duct is clear of blockages helps maintain an appropriate air supply to the engine, allowing the map sensor to function accurately. Also, routinely checking the integrity of all electrical connections linked to the map sensor ensures that the system can relay accurate data to the ECM. Adopting these preventive measures significantly aids in promoting engine efficiency and prevents unnecessary repairs and codes from arising. In conclusion, DTC P1128 serves as a critical indicator of issues surrounding the MAP sensor's performance within the Honda Accord models from 2008 to 2012. The troubleshooting process involves a series of systematic checks, starting from sensor diagnostics through vehicle operations and concluding with rigorous tests. Regularly inspecting component connections and ensuring a clear air intake duct can significantly reduce the likelihood of this DTC resurfacing, thereby enhancing vehicle reliability and efficiency. Understanding these aspects is key for both technicians and vehicle owners in addressing MAP sensor-related issues effectively while promoting routine maintenance for optimal operation. Please like and subscribe to the channel. See you next time.